Permapure up here now with Laura, and she's going to talk about her stuff, which is this and a bunch of other things that they do for sample handling and their dryers. We use a lot of, we use multiple things from Permapure in our systems quite a bit. So we have a bunch of different dryers and other things that we use for that. But Laura's going to talk about that, and then after that, we'll have lunch.
I'm gonna have to run out of the box. I like showing the box. I'm gonna have to run out to pick things up. So this is my box, right? So good morning. My name is Laura Geenen. I'm with Permapure. Permapure is a US-based manufacturer. We're located, our primary headquarters is in New Jersey. We also have a manufacturing site both in New Jersey and in West Valley, Utah. It's a little intimidating to be the last speaker before lunch, so I want to thank Rockwell Automation for the fantastic coffee break. Gives me a little bit of breathing room, so everybody's not running out of here for lunch. But I wanted to spend some time with you this morning to talk about some of the problems that you might be seeing in your CEMS systems. As Walt mentioned, we have a large variety of products. We're a sample handling company, sample analysis and sample conditioning for gas analysis. Here are a large variety of products, and I didn't want to talk about every single one. I can, but it takes about 4 hours, and I thought you guys didn't want to spend that kind of time. So when I was thinking about what might be most helpful for you, I wanted to talk about what kind of problems you see in CEMS systems. And we're moisture management experts. We're getting water out of your sample experts. That's primarily what we do in all of the products that we sell. So I want to spend some time focusing on that. Any questions to start? Good. Some people shot off questions immediately, so I wanted to make sure I took care of that. We are, I still need this. We are a 50-year-old company. As I said, we're based here in the US. For the past, I've been with the company for about 5 years. For 4 of those years, I was focused on the OEM analyzer side of the business. So I worked with companies like Teledyne and Thermo in getting our dryers and humidifiers installed inside their analyzers. About a year ago, we switched focus a little bit, and now I'm also working on the CEMS analysis side of the business. So as I said, I'm not going to talk about every single product, but I do have a catalog out on the table if anybody wants to see all of them. So our tagline for the company is breathe easier, be healthier. We have 2 sides of the business. One is a medical device business, which you can see up there, focused on patients who are receiving any kind of respiratory analysis. I'm a little nervous. I don't know why. I think it's the camera. I'm not normally this nervous when I'm talking in front of people, but it's been a little while since I've done this. So talking about this side of the business, the environmental monitoring side of the business. Talk about breathe easier, be healthier. That affects your side of the business as well. Talks about how we help you take water out of or particulates out of the sample conditioning system, make sure that you meet all the EPA requirements, helps the world be a cleaner place. On the E&S side of the business, though, we have a quicker tagline. We say condensation sucks. Oh. Okay. So why is this a problem? It's a problem because you're working with a hot, wet, dirty sample. They're trying to bring down to a clean, air-conditioned, very expensive analyzer. How do we do that? That's a big problem. You need something that gives you a sample conditioning system that gives you high reliability, because you have very high tolerances that you must be able to operate in. You need machinery that's reliable, that will give you less downtime and no unscheduled maintenance. You're working with hot and humid ambient conditions. Sometimes, depending on where we are around the world, we're working with ambient conditions which are up to 50 degrees Celsius. As I said, your system requires little maintenance, or as little maintenance as possible. So this is everything that's involved in sample conditioning. There we go. Starting your stack, going all the way down to your analyzer. Sample conditioning prevents unexpected water. When we're talking about unexpected water, we're talking specifically about liquid water. So coming out of the stack, as you've heard other companies talking over the past couple of days, you might have a heated line here that's just designed to keep the gas temperature above your dew point so that you can get it to primarily a cooler in most cases. We're literally dropping liquid water out of the sample. You're then taking a drier sample and sending it possibly to a polisher. We'll talk about that later. And then onto your analyzer. So why do we care so much? Because liquid water, unexpected water, costs you time and money. And that time and money shows up in corrosion, in unplanned maintenance, loss of water-soluble components, and inaccurate analysis. How do you know if you have unexpected water in your system? You might have corrosion, more downtime than you expected, seeing losses of water-soluble components, and inaccurate analysis. It doesn't have to crack open the whole system to take a look at this. If you start seeing these problems, you've got water somewhere in your system. So I want to get through, make sure we all are talking about the same definitions. So when I talk to a lot of end users, most of you people have inherited systems or been working with systems that have installed in your systems or in your facilities for a long time. You're dealing with the systems that you have in place. You may refer to the amount of water in those systems as relative humidity. When those systems were first spec'd out, somebody gave you a questionnaire, like Bob was referring to yesterday. Somebody gave you a questionnaire and said, how much moisture do you have in your sample? I don't know, we can measure it. You may give that to us in relative humidity. So relative humidity is the amount of moisture in the air that's relative to the maximum amount of moisture that the air can hold at that temperature. It is the actual amount of moisture is not changed by the temperature. So as air temperature increases, you get this on the news every day when you hear the weather report, right? As the air temperature increases, the ability for that air to hold more water increases, but the actual amount of water in the air doesn't increase. Does that make sense? Yeah. We can also refer to the partial pressure of water vapor, the total pressure that's associated with just the water vapor in the gas sample, as opposed to the total pressure of that gas in and of itself. Percent moisture by volume is also another measurement. It's the total number of water molecules versus the total number of molecules in the gas sample. And then dew point. Dew point is the temperature at which the relative humidity in the sample reaches 100%, and that volume of air can't hold any more water. All makes sense. There's a quiz coming. So you have to make sure that this makes sense. So the reason that I also bring this up is because when one of us asks you, how much water do you have in your sample? You can answer using any one of these. We can calculate, we can all calculate back and forth, doesn't matter. But we need the best estimate. And then what we do at PermaPure is try to overestimate. We try to build a more robust system than you may necessarily need, because what I'll show you a little later is when you may have some dynamic water volumes in your system and what may be causing those. Okay, so just again, going to hammer this point home, because if you understand this, plays into the entire rest of my presentation. So this is again dew point versus ambient air temperature, dew point versus relative humidity. So I gave away the answer to my quiz. So in this particular example, the blue container here represents 100% water volume in this sample, right? So this is the relative humidity is 100% at 10 degrees, meaning at 10 degrees Celsius, this air cannot hold any more moisture. So let's say this is a high desert area where in the morning it's cool or cold in this case, and you've got condensation forming on the ground, dew forming on the ground. Your air is completely saturated, can't hold any more water. The sun comes up, the temperature goes up. As the temperature goes up, the capacity for the air to hold water expands, and your relative humidity over the course of the day drops. So this is the pop quiz. For those of you that are quick, you saw the answer already. So in this particular example, later in the afternoon, when it's 35 degrees Celsius outside and the relative humidity is 22%, in this example, what's the dew point? 10, yes, exactly. Because the amount of moisture never changes. And actually, if you track the moisture in the actual air in any location over the course of the day, within a 24-hour period, you'll see that the moisture content in the air does not actually change that much. The relative humidity goes up and down, but the actual moisture content in the air doesn't change that much. Moisture content in your sample may or may not change, and that's what can cause uncontrolled water in your system. So how dry is dry? Just to give you an idea, most of you guys are going to be worried about the 4%, but just in case you ever work with other systems and you're wondering how dry do I need my sample to be, if you're just working in a controlled environment and you want to control condensation, again, at the point of an analyzer, you don't want to have any water damage to a sensor, you want to be about 8 to 10 degrees Celsius. Again, this is dew point, right? If for most CEMS applications, you're looking at about 4 degrees Celsius. We'll talk about why that may or may not be a good thing. If you're eliminating water for near infrared, where you want to improve your SEMS performance, you may want to target a dew point of -10 to -15. And again, if some esoteric applications out there, really low dew point requirements, IMS, some other methods, get about -40 to -60. Okay. We have a very young marketing department, and they're young in terms of how long we've had them within the company. They're doing a fantastic job of updating all of our information. So if you've been on our website recently, you might see that a lot of our brochures, our lowers changing, all that kind of stuff. They did not do this drawing. I just want you to know they're much more talented people. So you'll see some drawings that are very professional and some that look like a 5-year-old. All the 5-year-old did them. All the ones that look like a 5-year-old did them. I did them. So, but just to give you a representative example of what happens along a typical SEMS pathway. So everything you've talked about in the past couple days or past day or so in talking to some of the other suppliers, you know, coming out of the stack, you've got a heated sample line. The entire purpose of that sample line, again, is just to pass the water through. It's to get it from your probe down to the sample conditioning system in your shed without having any water drop out, having any liquid water happen in the system. Generally, in a lot of the gas conditioning systems that you have, you're going to have some sort of thermoelectric cooler that's going to condense the water out, and then that water gets drained out of the system. Your exit sample gas dew point, again, 4 degrees, you pump downstream, you manage this and keep no liquid, or end up with no liquid water in your line. Your pump's happy, your analyzer's happy, you're happy. But you can have areas of concern along the sample pathway that you might not be aware of while the sample is running. Changing ambient conditions can cause changes in moisture content in your sample. This may not be outside of the stack. This can be happening inside your process. If there's anything inside your process that changes the moisture content, if you're working with a fuel or other chemicals that are hygroscopic and you're on a high humidity day, it'll pull more moisture into those samples when you combust. All that water goes into the stack. If you have cold spots or zonal dropout in your heated line, or you don't have a heated line connection that's as robust as most companies will tell you it needs to be, you can end up with some cold spots in your heated line and end up with some liquid water in the line. Once there's liquid water in the line, it's really difficult to remove. So in the cooler itself, not all condensed water may be trapped or drained. This can be because there's more water expected in the line, or more water in the line than you expected. This can also cause, because not all of the water gets trapped by the thermoelectric cooler. And that's because water, when we think of liquid water, we think of big fat drops of water that are really heavy and fall out. But water can also be aerosolized, really small particles. We've got a pump pulling that through. It's going to want to move in the path of least resistance, pulled out of the cooler and into the pump. And that's called water carryover, which can lead to acid formation, corrosion, loss of analytes. You're going to have unscheduled maintenance in your pump and unscheduled maintenance in your analyzer. So this is not, again, my marketing team did this. Doesn't this look better? So this is not a SEMS specific process, but this is indicative of any kind of process that you look at, and SEMS is included in this. What's important, for those of you in the back, you don't need to necessarily read all of this little things. All you need to do is see the fact that this is a decreasing curve. So what we've got here, this curve represents what's happening in this process. And again, this can be any process. You've got the temperature of your gas sample and the dew point of your gas sample. As you move through your process, again, we're starting with a hot, wet, dirty stack, and we're trying to get to a nice, clean, cool, dry analyzer. So as we're moving down, the temperature is decreasing. That's extremely important. As we're decreasing, we're getting closer and closer to our dew point. Each one of the drying processes that you may have there is removing some water, maybe liquid water, maybe water and vapor. As it's taking water out, your dew point drops a little bit, but your temperature, gas loses temperature really, really quickly. We heard that yesterday. As you're getting through your process, it is possible at any given point in the process to drop the temperature of the gas below your dew point, and you may not even realize it. Usually when we talk about taking a measurement of what your temperature is and what your dew point and your humidity level of your gas, you're going to take one at the beginning of the process. You take one at the end of the process and say, okay, I know that I'm above my dew point. But anywhere along this process, you can lose some dew point. Excuse me, need a little water. Once you start talking, it's very dry in here. So anywhere along this process, you can lose temperature. Your temperature may decrease and then spike up again and then decrease. Any points of those declinations, you might see wrong button. You may see your temperature dip below your dew point. Unless you're absolutely tracking temperature and dew point along every point in your process, you don't know where it's happening. So it's really, really difficult to see. So as I said, your sample moisture volume may be dynamic, and that's what's causing some of your water dropout. Your drying solutions may only remove liquid water from the line instead of water and vapor. Dew point reduction may not reach below ambient, depending on what ambient is, depending on where you are in your process. The water vapor may not be low enough to remove, water vapor may not be low enough to remove enough water to get a low enough dew point along your sample pathway. There are two potential solutions for this. You can either increase your gas temperature along the pathway, or you can remove more water in vapor form. The idea, again, is to prevent water ever from being in liquid form. Sometimes it happens, but you want to avoid that and remove as much water in vapor as possible. How do we do that? Couple ways, and this may or may not be applicable, but just in case you're working with other processes, I want to make sure we talk through them. So we talked about a thermoelectric cooler and how that's really, really consistent, reliable technology that I think everybody is familiar with in this room. Typically, we're looking to remove, again, moisture down to about a dew point of 4 degrees. It's the industry standard for CEMS applications. And for a lot of people, this is just fine. But again, if you have a dynamic system where you're getting changes in your water, you may need to remove your moisture to a lower level. If you have acid gases in your system and you have any liquid water in there, that's what's going to lead to corrosion and the formation of liquid acids. Another type of technology is a water trap. Water traps are really low maintenance, cost effective. They're really easy to use. They have no moving parts, but they only remove liquid water. So, and if the physical thing is aerosolized water moves there, it hits a baffle, water drops out and is drained out the bottom, much like a thermoelectric cooler often is. But again, it's only removing liquid water. So this does nothing to change the actual dew point of the water, because that refers to the water that's in vapor form. Desiccant dryers. Lots of people are familiar with desiccant dryers. Desiccant also is really cost effective. It allows you to achieve sub-ambient moisture levels, really, really effective drying technology. However, it's very non-specific. So not only will it remove water, but it'll also remove a lot of other analytes from the gas stream. It does need regular replacement, and the performance degrades over time. So as that desiccant absorbs water, it takes on water and it reduces its ability to take on more water. So you see a declining curve in the desiccant performance. And finally, gas dilution. Gas dilution, really simple. Again, low maintenance, allows you to achieve sub-ambient dew points. It has no moving parts. It's really, really accurate. Analytes can become diluted when you're adding a sample gas in there, but this can be calculated. So as long as you're maintaining critical stability of that dilution ratio, it can be difficult to maintain this, but if you can do that, then this is actually a really accurate way to dry your gas. The problem is it does require access to dry gas, such as instrument air. And then finally, I want to talk to you about our Nafion technology. Nafion is a proprietary technology owned by Perma. The Nafion tubing drying technology. Nafion is actually a product of Chemours, formerly of DuPont, same company that makes Teflon, if you're familiar. So Nafion is a copolymer of Teflon, has a Teflon background with perfluorinated fluorocarbon side chains that end in a sulfonic acid. And that's the key to how Nafion works. So when we extrude Nafion, we buy it in resin from DuPont, we extrude it into tubing, and then we chemically treat it in a proprietary process. That process hardens the Teflon and activates those sulfur ion channels. And those ion channels act in chemical reactions to move molecules in and out of the Nafion tubing. and it does so on a very, very highly selective, highly specific basis. So to give you an example of that, because everybody asked me how specific it is, this shows you Nafión's affinity to moving water versus other chemicals. And again, if you can't see all the numbers in the back, basically it has a very high affinity to water and almost a negligible affinity to other chemicals. Our website is full of chemical compatibility information and retention information. So if you're working with a specific chemical that I haven't answered here, the answer is probably here on our website. We'll tell you if that sample will be retained by Nafión, will have variable losses, or will be lost completely. So as I said, Nafión readily absorbs water. The key feature of Nafión here is that it readily absorbs water in vapor or in liquid phase. As I said, Nafión is very selective based on, it's a chemical reaction. It's based on the molecules themselves. Commonly retained by Nafión, as you can see, are most common chemicals and compounds that you're going to be concerned with. NOx, SOx, CO2, oxygen, all of those are 100% retained by Nafión. Nafión is a well-documented, well-researched copolymer. So it's not just our research that backs this up. There are polymer chemists out there who write their PhD dissertations on Nafión as a polymer itself. So it's a very, very well-researched technology. So when you make these Nafión tubing into a dryer, it allows you to achieve some pretty interesting things. For example, using a Nafión dryer, you can achieve dew points down to -40 degrees. It flow rates up to 40 liters per minute. It operates up to a temperature of 100 degrees. And I told you it's got a Teflon backbone. So this doesn't mean that Nafión's going to melt if you get above 100 degrees. What you start to see is degradation in the performance of its ability to remove water from a system at above 100 degrees. So you're going to use this as part of or after a sample conditioning system. We use a tube and shell design, which has an inner Nafión core surrounded by a polymer or a stainless steel shell. And it removes water vapor based on the partial pressure of water vapor. Now you see why I had all those definitions up there. It removes water based on the partial pressure of water vapor. So it does require a purge gas. You have a sample gas generally flowing through the Nafión tube and a purge gas running in a counterflow to that sample gas. And as long as your purge gas is drier, as long as that partial pressure of water vapor in the purge gas is less than in your sample gas, you will pull water in microseconds out of your sample and into the purge gas, and then you can vent it. So it's a very, very fast, very effective way to remove water and retain the other analytes in your sample. The flows are sealed off from each other, and we do have a wide range of dryer sizes. So the pros are that you can achieve subambient dew point levels, up to -40 degrees, depending on the configuration. You keep those key analytes in your sample, provides you with a very consistent humidity level, no moving water or no moving parts, and no power required. The offset to that is it does require a purge gas. You can use instrument air, compressed air. There are lots of varieties of purge gas configurations. You can run a vacuum, for example. We know how to do this. We can help you do this. CiSCO knows how to do this. They can help you get a setup like this. One of the other drawbacks, especially in CEMS applications, is that Nafión is not compatible with ammonia. There are very few things that outright damage Nafión. Salts will coat the inside. Some of those can be washed away over time, but ammonia will irrevocably damage the Nafión. So it generally happens over a period of time. If you have a lot of ammonia, it happens very quickly. If you've got a trickle of ammonia in your gas flow, then it happens slowly over time. So you can get some life out of it, but eventually it will need to be replaced. It's really easy to tell when you have ammonia damage because the tubing turns black. It's easy to see. Give you an idea of where Nafión's performance plays against other technologies. This is just, to show you, these are dew points in Celsius and Fahrenheit, or percent water by volume. Wet scrubbers typically have a dew point output of about 70 degrees Celsius, natural gas combustion about 46. You go down to a thermal electric cooler. Again, we talked about that 4 degrees. Nafión dryers can get down in these particular applications. You can use a Nafión dryer after a cooler in this example. You're going to generally end up with an output dew point of about 18 degrees Celsius. The Nafion dryer removes 80% of the water left in the sample line after the cooler. So what we recommend is a system where after the cooler, we recommend putting in a dryer, and we call this a polisher. My show and tell looks like this. This is one of our PD dryers. They come in various lengths. This is a 50T dryer, which means I have 50 Nafion tubes in here. We have 100 tubes and 200 tube dryers. The more tubes that you have in here, the greater the flow rate you can get through here. We also have extended lengths, 12 inches, 24 inches, 48 inches, for example. The longer the flow rate, the higher your drying capacity. Most people don't need, for your types of applications, don't need a dryer that's going to be more than 24 inches long. But we do have them available if you need a really robust dryer. The longer the dryer, however, the more pressure drop you're going to see, the more force it's going to take to get your flow rate through. So we may need to adjust your flow rate or the size of the dryer based on what your analyzer requirements are for flow. As I said, we call this polishing. So we recommend that you put it in after the cooler. And this is in case you have any moisture breakthrough, comes through from your cooler. If you're changing atmosphere inside your stack or as part of your sample process, you can catch any water. Nafion dryers will also remove, we talk a lot about water vapor, but they'll also remove liquid water. So if you have any liquid water that breaks through from your cooler, it'll be caught by the dryer. So provides protection from those fluctuating moisture levels, prevents acid formation and unscheduled maintenance. Okay, so considerations in moisture removal. You know the actual dew point of your gas along all points of your process. In the environment, allowing the pathway be controlled, because that's the other option. You can't remove all the water. Can you keep a constant temperature along your entire sample pathway? Does any part of the process affect the moisture of the gas content? And do your current drying solutions remove enough water? Are you removing just liquid water? Are you removing enough water in water vapor? Any questions so far? Okay. Really quick. Yes. No, it doesn't. Dryer performance can deteriorate over time, meaning its ability to remove water can deteriorate over time depending on what is in your sample gas. So a lot of people ask me what the maintenance requirement is. If you're working with a clean sample, it'll run forever and will never need to be replaced. If you have the dirtier your sample, the more often it needs to replace. If you have things, again, that I mentioned, that like salts that coat the inside of the Nafion, it may need to be replaced. If you have soot or a lot of particulates, that may coat the inside of the Nafion. It can be very difficult to remove. So that may make it cause you to replace it sooner rather than later. But it doesn't affect the ability of the Nafion to retain those samples, because again, that only moves through, anything moves through the Nafion wall based on a chemical reaction. So if it doesn't bond with those ion channels, then it doesn't move through. Ammonia is a problem, yeah. It turns black from ammonia, yeah. So if you ever look at a Nafion dryer, you'll see over time it starts to turn sort of this golden yellow color. That's just natural oxidation. It doesn't affect the performance of the Nafion at all. It just changes color over time. We've tested that extensively. But you'll see when you start to see contamination, it'll start in spots. And again, ammonia is really easy, it's black. And it pulls the water out of the sample gas through the wall, and then it deposits it in the purge gas, and then the purge gas carries it away. Yeah, so it will, if you have very wet gas, some of that moisture is going to be trapped inside the wall. So if you stop your system, for example, and you still have a wet gas sitting on one side of the wall, usually inside the tube, right? Some of that moisture will leach into the tubing, and the tubing does expand a little bit and it'll retain. So if you stop your system while the tubing is, let's call it wet, and then turn it back on and start your purge gas up, initially you'll get this very fat pull of water out of the dryer because the purge gas will suddenly pull all that water that's in the sample wall out of the wall and into the purge gas. So it will retain a little bit within that sample wall, but for most people's applications, it doesn't affect anything. Okay. Real quick, I'm going to talk about some new products. Not going to spend a ton of time on this, but I just want to make you aware. We do have a new hybrid sample cooler, also called a vortex cooler. This again is based on our Nafion technology. That's that guy right there. It's a passive system that requires no electrical current. It runs off of compressed air. So it's ideal for sites with limited power where non-electric products may be desirable. It again has no mechanical parts. It's low maintenance, increased reliability. It can be stack mounted. And again, it utilizes our Nafion technology. And next slide shows you what the inside of it looks like. So you've got your inlet. Your inlet tubing is going to come down here. This is a heat exchanger. We actually use the heat exchanger to pull heat off the sample gas. And then we use that to keep the Nafion dryer warm. Again, because we're trying to prevent liquid water from happening in your sample. We take the heat off of your sample gas. We use it on the purge side of our Nafion dryer, and we prevent it from causing any cold spots inside this cooler. It runs on, as I mentioned, compressed air. We pull the compressed air through. Part of it runs through the purge side of the PD dryer. So again, that's how we're taking moisture out. And then part of it actually runs through a vacuum, an inductor, and it creates a vacuum. So it pulls sample and pulls that compressed air through the cooler itself. That's a simple, very quick version of how it works. It's a new product we came out with last year. We started selling it. Primarily, we developed this for the Asian market because that's ideal for working at higher temperatures in locations that don't have air-controlled sheds. So they mount this outside. Also because they don't have to worry about cold temperatures in the winter. We've recently moved some into Mexico as well. So it's a growing product line for us. I do have more information, so you can see me after if you have any questions. And then I wanted to announce, if you weren't aware, last year, Permapure bought Claiborne Labs, which is a maker of heated sample lines. I am not a heated sample line expert. I do have them, and I'm happy to put you in touch. I'm just going to run through real quick and tell you about how our sample lines work, what the technology behind them is. And again, I will make sure that you have the contact information for our heated sample line expert in case you have any questions following up. So as you know, heated sample lines are used to transport gas from the stack down to your sample conditioning system. The idea is to hold the gas temperature above the dew point so you don't get any liquid water formed. Now, you have a sample line. The sample line with the heater, usually covered in insulation. There's an outer covering, and then what are all Don't lose the microphone. Okay, so you've already seen the anatomy of a lot of heated sample lines, and you're going to see some more. So I'm not going to spend a lot of time talking about other types of sample lines. I just want to tell you how we put together our own sample lines. We use electrical resistive heat tape. So there is a resistive heating element on the inside that has thin flexible dielectrics on the outside and a radiant reflective surface covering it. And then on the other side is an adhesive. So any thermal energy is transmitted either towards the tube, or if it's transmitted away from the tube, it's reflected back down again and transmitted towards the tube. So we try to make it as an efficient a heating system as possible. So this heat tape that I just described is then wrapped around the sample tube. That makes it, the precision winding provides very consistent heating along the entire circumference of the sample tube. So you don't get any heat gradient that can happen in other lines because it's wrapped consistently around the entire tube. And that's also why I have a little show and tell. So if you want to see this afterwards, you can see how precisely we do wrap our tape. So what this does then is makes it really flexible. So we don't have the same kind of rigidity issues that you can see in other heated sample lines where they're very susceptible to breaking or damage. They're very rugged and very flexible, and they become more flexible as they're heated. So they're very ideal for rugged applications. Good, highly efficient architecture. They have a very rapid warm-up time. We have customizable solutions for power. They're all listed there. And the designs themselves are customizable. So we do have several sample line materials, Teflon, stainless steel, polyethylene, insulation materials. We have several options on those. We can do up to 6 heated sample lines and 6 unheated sample lines, as well as 24 pass-through wire. And we can make that in any custom configuration that you're looking for. Again, talking about cover options that are available. Here are some things that are noticeably different about the Claiborne lines from others that you've seen. We use integrated strain relief loops that we build at the time of manufacture. So you don't have to figure out, how do I securely wrap this and pull this up to the top of my stack without damaging the tube. We customize these and we install them along the length of the tube. And we'll talk to you about where best to install those. And they're very, very, very sturdy. So you can hook that up, attach it to your crane, and pull the whole thing up. And again, it's a very robust design, so there's less concern about damage during installation. The heat technology, though, does require that the ends are factory finished. So these can't be cut in the field. And I know that can be a challenge for some people, but again, if you're looking to replace an existing line and you can measure that line, then we can cut exactly to your specification. And if you have concerns about how to measure that line, please contact us. We can give you some guidance on how best to get an accurate measurement of the line that you need. Those are the major differences that I wanted to talk about. Everything else I think we've discussed in other presentations. Are there any specific questions about the sample lines or the hybrid cooler that I mentioned? Fantastic. That's all I've got. So that's my contact information. I'll be here for the rest of the day. And if you have questions about heated sample lines, I'll be happy to put you in contact with Tim Edge, who is our heated sample line expert. Thank you very much for your time, and I hope you enjoy your lunch.